Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 617, merge two binary trees. We're given two binary trees, root 1 and root 2, and we're told that we need to merge them together. And the merge rule is basically that if the two nodes overlap, then we have to sum the node values up, and that will be the new value of the merge node. Otherwise, the not null node will be used as the node of the new tree. So in this example, we've got 1, 3, 2, 5. So we've got this tree and this tree, and these two trees merge. So 1 and 2 becomes 3, 3 and 1 becomes 4, 3 and 2 becomes 5. When we get to 1, well, our tree 2 has 5 as a left node. So although all the tree 2 doesn't, we put the not null node being used as the node of the new tree as a new subtree. So basically, we imagine that we basically put one on top of the other, and then that kind of merged example is what we would get. And we are given another example as well, and we're given some constraints. So let's hop into the code. We can use a depth first search approach because we've got two binary trees, and we can do this basically recursively. We'll take a root 1 and root 2. Actually, let's just say tree 1 and tree 2, just to make this a little easier. And we'll set our base cases. If not tree 1 and not tree 2, then we can just return none. Okay, that's perfect. What happens if not tree 1? Well, then we need to return tree 2, because this is the not null node. And if it's the other case, if it's tree 2 that's not null, then we just that's null, then we return t1. Okay. So these two are now done. What happens if they both exist? So, well, then we're just going to set t1 plus equals, so t1 being t1 plus t2, or should I say t1 dot val plus equals, because we're basically told that if the two nodes overlap, then we have to sum the node values up, and then we can just return, in this last case, t1. But before we do that, we also want to do the recursion. So we want to say t1.left equals depth first search, and we'll take in t1.left, t2.left, and we'll do the same for the right subtree. So we'll say t1.right, t1.right, and t2.right. And then basically we will return the depth first search function. So now we've written up our function. Let's pass in our two roots, so root 1 and root 2, and let's run our code to see if our code works. Yep, let's double check by submitting. Fantastic. So our code is accepted. So in terms of time complexity, we're looking at an O of n plus m time complexity. So basically O of n. And space complexity, well, space complexity is going to be O of, let me jot it down over here. So space complexity is going to be O of the maximum of h1 and h2, where h1 is the height of root 1 and h2 is the height of root 2. So basically whatever tree that we're given is the tallest, it's going to be the height of that. So it can basically just be dumbed down to O of h. So that's a little abstraction we've done. So O of n plus m, or O of n time complexity, and O of h space complexity. I hope this video was helpful, guys, and I'll catch you in the next one.